Recording again, looking at the first waveform, which is the one without the supercapacitor. I'm just going to pause it and just give it a bit of a talk on it. So we're starting at 13. See the current, CUR on the left hand side. That's the current. That's the live voltage, and the real-time voltage. And then the max is the max, and the minimum is the minimum. So the minimum on this was 10 volts. So let's just go. Notice that I've engaged the lift pump. The hydraulic pump, and then it's 12.2, and so what it is it has read 10 minimum, but then we can't get it spot on. So there we go, she's loaded up 12.3, 12.9, 12.2, and I've dumped it again. So every time you see a dip, a spike going down, that's when I'm engaging the lift pump. So it's 12.3, so it's holding 12.3. Now 12.9 when I release, and then I'll do a motion 12.9, 13, she's recovered. There we go. 11.8, we've engaged something there. Could be the tilt. 11.8, 11.9, 11.8. Now it's 12.7. Now she's bounced back up to 12.9. And then now there we go again. We've engaged the motor again. The current, see the CUR. That's the live voltage. So it's dipped down to 11.8, holding steady. 11.7. Now I've released. So there we go, 12.9, and that's it. So that's the end of the no supercapacitor. So let's go and look at the waveform with the supercapacitor. There we go. We're starting at 13 volts, the current, the live voltage. The maximum is 13, minimum is 11.4. There we go. Let's see the dip. There we go. See how it's holding. I've engaged the motor, and it's at 12.6. See how it's very high, 12.7, 12.8, 12.4, going down, and there we go. It's recovered. You can't really see much of the sharp. It's all very smooth curves. 12.8, 12.9. There we go. I've engaged the motor again, and it's down to 12.3 on the left hand side, which is the real time, the current reading. CUR is current, not as in amperage, but the current as in real time current reading. There we go. 12.1, 12.12. 12.5, 12, 12.2. There we go. I'm doing a whole long. There we go, and she's starting to recover. And there we go. That's it. So as you can see, that the current reading, the real-time reading, is holding at a much higher voltage, and the minimum detected is only 11.4, which is only for a microsecond. We couldn't even pick up 11.4 on the real-time reading because it's just a spike. Yeah, hopefully that gives you a good understanding. And also just to note, why am I only reading a 14 volt system? So I've got 16 cells. My this voltage tester is meant for a 12 volt application, so I've only clipped onto 4 cells out of the 16. So out of the 48 volt, I'm taking reading only on a 12 volt bank of 4 cells, so which is the same. All it is just narrowing down, looking at a section of the battery versus the whole 48 volt system. So hopefully that gives you a good understanding on the what is actually happening with the supercapacitor and battery cells in parallel, and just to see the difference in performance with and without supercapacitor. As you can see, that the supercapacitor takes the edge, the sharp edge out of the current, the voltage dipping down really low, and with the supercapacitor, as you can see, it's only just a very smooth curve all the way through, up and down, very smooth, very long smooth curves. Whereas with the without the supercapacitor, it's 90 degrees. It's very sharp, very jagged on the waveform. Anyway, cheers.